So let's go directly to my talk. And again, I have 3 questions. In this case, I will try to comment on these questions, and then we will have final discussion all together. Why should we consider pharmacogenomic approach in wine stimulation and ART? I will try to unravel the impact of polymorphism, what we know at the moment concerning the FSH receptor in wine stimulation. And I will mention something that we have available for LH system, including LH and LH receptor in terms of research. So why pharmacogenomics? You know that pharmacogenomic approach is quite common in oncology, in other fields for matching patients and protocols. But when we talk about pharmacogenomics, we usually think about the interaction of a given drug with the receptor, the capability of stimulating a given biological effect. But we don't have to forget that allelic variant of a specific molecule or receptor has also an impact on drug metabolism, clearance, persistence, bioavailability, not only in terms of biological activity in a given cell. And I totally agree with Antonio Capalbo when he says that when we think about preconception genomic medicine at the individual level, when we do genetic risk assessment and we estimate reproductive genetic risk, it makes sense, in my opinion, also put inside in an NGS platform for carrier screening some information about polymorphism of gonotrophins, their receptors, or other variables in the future that can be implicated in metabolism and biological activity of drugs we use in the clinical practice for IVF. Because the idea is always to find the right drug for the right patients at the right dose at the right time. This is the ideal, obviously. So there are so many trials demonstrating the historical by the Brussels group, by Diakopoulos, and followed by papers by Nikos Politsos, all in the same direction. Our aim in the clinical practice is maximizing success. And the first point is optimizing the number of eggs retrieved. This is something that Robert mentioned before. And you can see that if you consider only live birth rate in fresh cycles, you have the increase up to 15 eggs and then a plateau. But pay attention, if we consider the cumulative live birth rate, the cumulative live birth rate continues to grow, even overcoming 20 eggs. So maximizing means having the optimal fourth foy, meaning employing and all the ovarian reserve of the patients when possible, or even accumulating when it is not possible. So we need more eggs. And so we need sensitive follicles. We need to find the right drug for having what we said before in the morning. So again, is another angle to see the same we had been talking about before, to patients with similar in age and everything, similar follicle count, but totally different sensitivity to gonotrophins. And probably if we knew before stimulation that that patient is more or less sensitive, we can avoid a picture like this, meaning that a very good ovarian reserve, but few follicles growing. So probably in this patient, something at genetic level can be impaired. So if we knew before this, probably we can adapt since the first stimulation our clinical practice to this. I don't know what's going on. So the second point, so the concept here is, we said pharmacogenomic are useful because we can understand by genetic point of view before stimulation how to maximize success, how to improve fourth, how to improve foy. But this is an idea. what do we have in research and what can we spend at the moment in the clinical practice with this intention. So first step was in the last year, 2 years, we tried to put together all researchers that gave attention in the last years to possible pharmacogenomic approach. This is a survey, but is a Delphi approach, meaning that we tried to understand if at the general level, in the mindset of clinicians and people involved in research, but in this field, but not wholly, what is the perception of the available data on this topic. So this is, I will not mention all the stages of the Delphi consensus. What is important to understand is that experts elaborated statement. This statement had been voted by expert initial panel and enlarged extended panel of experts. And so everyone has to give comments and to provide an agreement or disagreement. And only statement that following different steps of elaboration reached 66% of agreement were used and mentioned as valid. So any statement that was not consistent with this 66% was reported as not approved. So I think that we can follow these for understanding and analyzing some clinical data that are at the moment available. The first information is I want to start with the FSH receptor allelic variant. So this is just to give you an idea of how many differences we can find in the distribution of allelic variant worldwide. So this is the famous 680, the most famous FSH receptor. This is minus 29. And you can see, for instance, that the allelic variant, the wild type in Europe, for instance, of minus 29 is very high if we compared with the United States, where the polymorphism, the implicated polymorphism, is almost 50%. So in a given country, the distribution of allelic variant can be different as the color of eyes, as any other phenotype. And so we have to take into account when we work in a given country about the distribution of any given polymorphism. And to go a little bit inside, the most studied FSH receptor polymorphism was the 680. It is intracellular domain of the FSH receptor in position 680. Usually an asparagine is there, but in 20 to 40% of population, there is in heterozygosis or even homozygosis serine. So the wild type is asparagine, serine is the allelic variant, which is less common. What we know at the moment is that the carriers of this polymorphism in vitro show dramatically different kinetics in terms of cyclic AMP production. So if we have a patient, granulosa cells of a patient carrier of serine in this position, the cyclic AMP following FSH stimulation is dramatically lower. And these patient carriers of this polymorphism are perfectly consistent with normality. The phenotype is normal, but they have a little bit longer interval between cycles and FSH levels, basal levels in the range of normality, but above the 80-90 percentile, so the highest for any given age. So demonstrating that even in human heroic cycles, some differences are there. We are not talking about pathology, we are talking about differences. And the carriers of this polymorphism have something different. Even we can probably, I cannot say identify, but we can imagine that the patient can be a carrier only analyzing some clinical activities, some clinical features. And this is the same. You can see the difference. And when asparagine is there, the cyclic AMP production is more rapid, and also higher in terms of quantity. So the transduction system is more efficient. So many groups studied before and after we did it, the impact of this polymorphism on ovarian stimulation. But I mentioned this paper not for self-celebrating, but because it was the only paper that has been performed in testing this polymorphism, serine polymorphism, in patients classified as hyperresponders, the patient that became later Poseidon 1 and 2. So patients who have ovarian resistance to FSH, meaning that require, despite normal ovarian reserve, require higher doses of FSH and a significantly higher incidence in terms of presence of serine 680 polymorphism. This is a meta-analysis. You can see that the sample size is quite huge. The I-square is relatively high, but the effect seems to be there. We have more than 1,000 observations per genotype, and serine carriers, even at heterozygote status, are associated with lower number of oocytes and are also associated with higher consumption of gonotrophins. So if we have a patient that has a serine, this patient can have a normal response in terms of number of eggs, but probably this patient requires 1-2 additional days of stimulation, or probably an increase of the dose during stimulation, or probably an initial higher starting dose. This has been also confirmed again. I mentioned this paper because it has been published after 2018, the year of the meta-analysis. So all the information seem to go in the same direction, that this polymorphism seems to have an impact on ovarian sensitivity to gonotrophins. And that's the reason why, at least for the number of eggs, in the Delphi consensus, the expert found agreement above 66% in thinking that this polymorphism is associated with less performing ovaries during ovarian stimulation. Let's move to another one, is -29. The allelic frequency of this polymorphism is a little bit lower in the general population, but in this case, the combination AA is associated with the lower expression of production of cyclic AMP and lower activation of the receptor. And also this polymorphism has been studied and has been associated with the lower ovarian response in terms of ovarian sensitivity. So higher doses of FSH are required when this polymorphism is present. This is an amazing study performed by the group of Nikos Politsos and in collaboration, I think, with Brussels, and is a very, very nice. And at the end of the day, in this paper, what has been provided as information for the first time is the combination of different polymorphisms. Because what is important is not only the fact that a given polymorphism can be associated. We have inhibitory and activatory polymorphism. And sometimes the association of two inhibitory polymorphisms can make the difference. And they are sufficiently frequent in the population for considering that the association is more common than expected. And that's the reason why, despite more research is required, the panel of experts also approved the idea that this polymorphism is worthy to be considered for future research or even tested according to your protocols and your facilities in having an information like this. So, but the question is, I have this polymorphism there. I know that the FSH consumption will be, sorry, I know that the FSH consumption will be higher. I know that probably I will have one or two oocyte less than expected, but what can I do for counteracting, for balancing this? We don't have interventional trial, few interventional trial, but this is very elegant, performed by the group of Manuela Simoni some years ago. And you can see easily here that we have patients that have wild type treated with 150 and patients with the polymorphism treated with 150 international unit of gonadotropins. And you can see that the ovarian response in terms of estradiol is significantly higher in wild type group. But only adding 225 additional international unit of FSH, you can have in this patient with the serin homozygote situation, you can have the same results of wild type. So the information here is that if you know before the genotype, you can decide if starting with 150 or if for optimizing result, you need to start with 225. So that has been also proven by Renato Fanchin, that has proven that in terms of FORT and ovarian response, we have having a starting dose of 300, we can balance, counteract the polymorphism. And so we don't need probably to test this polymorphism, because having a little bit higher dose as a starting dose, we cover the polymorphism, we counteract. But there is a problem here. We can say, why not starting in all patients with 225 or 300? We have also maximum recruitment oocyte. Everyone is happy because we have more blastocysts and whatever. But please consider that a problem that we know very well, that is progesterone rise, moving too much progesterone during folliculogenesis and ovarian stimulation, is totally related to FSH. So it is not an LH-dependent mechanism. If you push too much the system with the FSH, you move more progesterone. So progesterone rise is related to exceeding FSH response. So if you have a system that is very, very sensitive, meaning that has wild type for both -29 and 680 polymorphism. So the system is very able to produce cyclic MMP, and you push this system with the 300. Don't we run the risk of increasing the risk of progesterone rise? What I'm telling you is to totally change the mindset, considering polymorphism not for deciding in which kind of patient have an higher starting dose, but for considering in which kind of patients it's more prudent to start with a lower dose, because the system is sensitive and you can have optimal result with a lower dose without increasing progesterone. So that's the reason why I asked Chris, probably you remember some years ago, just before COVID, we said, you have an incredible database, but why don't we try to understand if the polymorphism 680 can condition the progesterone rise? And so Chris and Nikos reanalyzed data. And at the end of the day, surprisingly, the polymorphism has had no correlation with the progesterone rise. But all these patients were treated with a starting dose of 150. So it is not expected in patients with a dose of 150. Some years later, I was not able to do it, but another group that published very well in RBM Online found that if you have a flexible starting dose, flexible protocol, including patient with 225 and 300 international unit, carriers of carriers of serin you can see here, carriers of a serine, meaning more resistant receptor polymorphism at the significantly lower levels of progesterone. So I think that it is worthy to be further analyzed in the future. The idea that very sensitive system should have lower doses for having optimal FOI, but without moving too much progesterone. More resistant system can have higher doses, probably for having maximum FOI with a lower risk of a progesterone rise. Just 2 minutes about the LH system. This is just to give you an idea that the research was focused in the last years, 80% of research on FSH receptor. We don't have so much information about implication of LH and LH receptors in terms of pharmacogenomics and sensitivity to gonotrophins. One of the few things that we know is that there is a very common allelic variant of LH, not LH receptor, LH, which is probably a little bit less performing because of reduced half-life. And in an analysis that we did with the pitaumide some years ago, we found that carriers of this allelic variant of LH have an apparently normal response, but require higher doses of FSH. They consume more FSH. This is, one could say, the variant regards LH, but this patient consume more FSH. It's not surprising because LH is crucial in supporting granulose and T cells during folliculogenesis. So if the LH is lower, probably we don't know it, the LH bioactivity or performance is lower. We don't know in the clinical practice because we don't test for polymorphism. What we see is that the ovary is resistant. We increase the dose of FSH. And we counteract because you can, increasing FSH, you can try to force some problems at the LH level. But another nice, very nice information derives from some studies that has been performed in the LH receptor. There is this polymorphism in position 312 of the LH receptor. Even in this case, we have two allelic variants, serine and asparagine. And there are many trials demonstrated that this polymorphism can have an impact in terms of sensitivity to both endogenous and exogenous LH. And this is a very historical paper demonstrating that patients that have the variant SS required a significantly higher doses of FSH again. So again, a polymorphism regarding the LH system, in this case, LH receptor, in a clinical practice has been associated with higher consumption of FSH. So if we know before that an LH polymorphism or LH receptor polymorphism is there, we could probably consider to start stimulation with LH directly associated with the FSH. And this is my last study, 2%. This is what has been considered by the group of Ramaraju in India. They are very active in studying polymorphism and pharmacogenomics. They didn't test, they test all the patients for this polymorphism, but they didn't consider it was blinded. They didn't consider it was a retrospective analysis, association analysis, but they used this protocol. A patient with good ovarian reserve, they started with the agonist long protocol, a standard dose of FSH. But patients that on day 7 had a lot of follicles, but not growing follicles, were randomized to receive LH, not randomized, they received LH, sorry, with a different dose according to BMI. So starting with FSH, and only in case the ovarian response was not satisfactory in the first 7 days, they add during stimulation recombinant LH. And what they found is that when they analyzed the result with respect to the LH receptor polymorphism, they found that patients that had wild type 312 required less LH supplement, while patients having in heterozygosis or homozygosis the allelic variant of this polymorphism, the more resistant one, required significantly higher doses of both FSH and LH. So I think that this is very important information, because if we knew it before, we could have probably considered to directly start with an association of FSH and recombinant LH. So I skipped this, and I conclude to tell you that there is at the moment an agreement about the fact that data on LH system are limited and needs more research, but they are worth to be investigated. This is a paper that an analysis that we did we started many years ago, but we completed 2 years ago. And just to tell you that there is another polymorphism, promising polymorphism of LH receptor in position 291, which the variant is a C, and the allelic frequency is very low, but it's probably 5%, 5-7%. But even when in heterozygosis, when this polymorphism is present, you have a dramatic increase in the number of eggs, in the fertilization rate, and even in cleavage rate. What does it mean? This is the first evidence of an LH receptor polymorphism, which is activatory, not inhibitory. So the frequency is very low, but if this polymorphism is there, the system is very reactive. So can you imagine what happens if you have wild type for FSH receptor, wild type for -29 FSH receptor, and you have activatory polymorphism? Probably this combination can increase the risk of progesterone rise or even the risk of ovarian epistimulation syndrome. This is just an hypothesis. So we have no answered question. We don't have randomized controlled trials. We have only association studies. So I do think that only real world data in the future, if in NGS platform, in a very cheap way, we can test all the combination, all the polymorphism, probably in the future, from this combination of polymorphism, we can hypothesize to have a better matching of patients and protocols according to pharmacogenomics. So thank you so much for your attention.